Hello, my name is Tara, and this is ETS-Lindgren. Follow me as we gain knowledge from leading industry experts in audio, medical, filters, chambers, and much, much more. Welcome to Tara's Tech Talks.
Hi, welcome back to Tara's Tech Talk. This is our second special episode focusing on the IEEE EMC Symposium and, just to learn a little bit more about speakers. Today, I'm here with Zhong Chen, ETS-Lindgren's Director of RF Engineering, and also Yibo, Wang, who is the RF engineer. So welcome, Zhong, Yibo.
Yeah,
Thank you for having us.
Yeah, thanks. Glad to be here.
So, Jens, can you start by telling us a little about yourself and also what you do at ETS-Lindgren?
All right. Like Tara said, I'm Director of RF Engineering at ETS-Lindgren. So I work with a group of talented RF engineers designing and supporting our RF products, including antennas and field probes, anechoic absorbers and chambers and things like that.
Yibo.
Hey, I work as an RF engineer in the engineering department. I mainly work on chamber design, modeling, absorber modeling, and RF testing.
So, Zhong, understand that you will be participating in a C63 tutorial. So can you tell us a little about the topics you'll be presenting?
Sure. Yeah. So this is a workshop that I'm going to be presenting with a couple of our C63 committee members on C63.25 documents. That's my part of the presentation.
Okay.
So specifically, I'll be talking about the C63.25.1, 2, and 3, the three documents. And these are the standards that C63 recently developed for testing, for measuring RF chambers and site validation measurements. So these are important for example, for EMC test labs and personnel for validating their sites. And I will be presenting things like the specific requirements and what we're developing on, and also some of the background information on these documents.
So Yibo, is it true that you actually submitted a paper, and can you tell us a little about that?
Sure. We did submit a paper about our recent developed time gating library.
Okay.
So gating is a well-established technique used to isolate or remove responses in environment with multiple reflections. It is commonly employed in vector network analyzers.
Okay.
However, we have created a software library that offers users greater convenience, flexibility, and control comparing to relying on the gating function in VNAs.
So Zhong, in addition to the tutorial, you're participating in a workshop, right?
Right.
So what topics are you going to be covering?
So yeah, I've been presenting with a couple of industry experts on measurement uncertainties.
Okay.
Specifically, there are a couple, we're talking about measurement uncertainties for my topic. It will be measurement uncertainties for site contributions to EMC measurements. So in this whole tutorial series, I think there's a couple of guys from NIST and also a couple of guys from industries. We'll be together talking about how measurement uncertainties can be assessed and how that impacts your measurements for EMC testing.
That should be very interesting, huh? Cool. So Zhong, I know you have been quite busy with the preparing for the IEEE Symposium. And also, I think we're doing a demo, right? So can you tell us a little about what this demo is about and how significant this would, of the measurement techniques we're presenting?
Sure. Yeah, I think Yibo mentioned we're going to be, he's going to be talking about the time domain gating library we developed. And so actually, we're doing two demonstrations. I think one of them is actually a demo of the software libraries and also how to apply this gating techniques and what are the kind of the background information and theories behind it and how you use it in your actual measurement, how that would bring convenience to your measurement data post-processing. So that's one part of the demonstration we'll be doing. And the second demonstration is actually pretty synergistic with the other talk I'll be giving, the C63.25 document.
Oh, okay.
Because that is the specific demonstration is using mode filtering technique to measure site VSWRs for site validation measurements. So that is a proposal we think has a very high chance it's going to be developed into the standards in the C63.25.3 documents. So that will be a very interesting demonstration to show how one would be able to maybe perhaps in the future how they validate their test site for above 18 gigahertz measurements.
Wow, so that means we actually are going to learn theory from your tutorial, but then we actually get to see the demos, to see the real deal.
Hopefully then you get a hands-on view of what's going on, not just the theory. So I think that's a very good combination.
So Yibo, so in regards to the demo, is there anything you want to expand on that, just to share a little more with us?
Yeah, sure. So in the demonstration, we will show the ease of of using the gating library for data post-processing. We will begin by marrying the vector response of two antennas, and we will utilize the gating library using a MATLAB script to gate the vector response. So using the MATLAB script, we will demonstrate how the users can easily select the gate parameters, such as gate width, gate shape, gate edge, and furthermore, we will demonstrate some other cases, highlighting the advantages of our gating libraries comparing to the gating function of the VNAs.
Wow.
For each case, we will utilize the library for real-time data processing.
Yeah.
So through this demonstration, we aim to showcase the versatility and the effectiveness of our gating libraries in different scenarios.
So Zhong, Yibo, thank you so much for joining us and tell us so much about what we can look forward to at the IEEE Symposium. So please make sure to check out the program of the symposium and stop by and see us at booth 301.